Ever wish you could just dive into data analysis, without the whole setup hassle? That's what's so cool about Microsoft Fabric Spark Compute. That's what we're exploring today. Think of it like an express lane to insights. You shared some Microsoft Learn articles about managing Spark and Fabric, billing concurrency, all that good stuff.
Yeah, it's a fascinating area. By the end of this deep dive, you'll not only know what these features are, but also why they matter for your data projects in Fabric.
Okay, let's unpack this. Fabric offers starter pools and Spark pools for compute. Sounds like choosing the right pool can really impact my workflow.
It definitely can. Imagine starter pools as your on-demand data playground. They're always ready using medium-sized nodes, and you can spin up a Spark session in seconds. No setup, and you only pay while your notebook or job is actually running. Perfect for quick explorations or testing out a new idea.
That's super convenient for those times when I just want to get in and play around with some data. But what if I need more fine-tuned control? Is that where Spark pools come in?
Exactly. Think of Spark pools as your custom-built data analysis powerhouse. You get to choose the named node size, how many nodes, and even set up auto-scaling rules. And like starter pools, you're only billed during active use.
So it's a trade-off. Quick and easy with starter pools versus more control with Spark pools. But there's a 3-minute setup time for Spark pools, right?
Yeah, because Spark needs to provision those nodes from Azure. But think of it this way. Those few minutes are an investment in getting the exact configuration you need for your heavy-duty data tasks. It's like taking the time to sharpen your tools before starting a big project.
Makes sense. Speaking of tools, the articles mention limitations on node sizes. Can you break that down for me?
Sure, node sizes are like the engine sizes for your Spark compute. They range from small, with 4 virtual cores and 32 gigabits of RAM, to XX large, packing 64 cores and a massive 512 gigabits of RAM. But there's a catch. If you're on a trial Fabric SKU, you can't access those powerhouse X-large and XX large nodes.
That's an interesting limitation. So if I'm working with massive data sets or complex models, upgrading to a paid SKU might be necessary to unlock that extra horsepower.
Precisely. It's all about matching the resources to the demands of your analysis. Now, while we're on the topic of optimizing resources, let's talk about auto-scaling.
Okay, auto-scaling sounds intriguing. It's about dynamically adjusting resources, right?
Exactly. You set your minimum and maximum number of nodes, and Spark dynamically adjusts based on what your workload needs. This way you're not paying for idle resources, and you get the right amount of compute power at the right time. It's like having a smart assistant that scales your resources up or down based on real-time demand.
That sounds incredibly efficient. But are there any downsides I should be aware of?
Well, one thing to note is that the default settings might make scaling down a bit slower than you'd expect. Fabric prioritizes overall efficiency, so if you need faster scaling down, you might want to tweak some configurations.
Good to know. Now, what about dynamic allocation? That was another term that popped up in the articles.
Dynamic allocation is like having a flexible crew that adapts to the size of your data project. It means Spark automatically requests or releases executors, those workers that handle your data tasks based on how much work there is to do.
So instead of me having to manually configure executors, Spark just figures it out on the fly.
That's the beauty of it. This is especially useful when dealing with fluctuating data volumes. You might start with a small data set, but as your analysis expands, Spark automatically scales up the workforce. No more manual adjustments or worrying about under-provisioning.
This is making me rethink how I approach my data work in Fabric. It sounds like Spark is designed to take a lot of the guesswork and manual configuration out of the equation.
It absolutely is. Microsoft has put a lot of effort into making Spark and Fabric as streamlined and user-friendly as possible. But of course, there are always those finer details and configurations that can make a big difference in performance.
Right, because even with all this automation, we still need to be mindful of cost. How does all of this impact my billing?
That's where Fabric capacity comes into play. Think of it as your overall budget for compute power. You purchase it via Azure, and it's measured in compute units or CUs. Here's the key. 1 CU equals 2 Apache Spark E-cores. So if you have an F128 capacity, you have 256 Spark V-cores at your disposal.
Okay, so it's like I'm buying a certain amount of processing power that all my Spark workloads share.
Exactly. And that's something to be mindful of, especially if you have multiple workspaces within the same Fabric capacity. There's the potential for contention, meaning your workloads might be competing for those resources.
That makes sense. It sounds like I need to be strategic about how I allocate those resources.
Yeah.
Is there a way to track where all this Spark compute is actually being used?
Absolutely. The Fabric Capacity Metrics app is your go-to tool for understanding resource usage. It shows you how much capacity is being used for all your workloads, including Spark. You can see how much compute is going to different operations, like notebook runs, for example.
So it's not just about the overall capacity, but also about understanding how that capacity is being distributed across my different tasks. That's really helpful for identifying potential bottlenecks.
Exactly. It's all about visibility and having the insights to optimize how you're using those valuable Spark resources. Now let's talk about what happens when multiple people are trying to use Spark and Fabric at the same time.
That's what I'm really curious about. How does Fabric handle those situations where everyone is trying to run their Spark jobs simultaneously? Does it become a data traffic jam?
Well, Fabric has a built-in system for managing those scenarios. It's called cores-based throttling. Essentially, jobs are submitted based on the capacity SKU you've purchased. If everyone tries to run resource-intensive jobs at the same time, you might hit the limits of your capacity.
So it's like a safety valve that prevents things from overloading. But what happens to my jobs if they hit that limit? Do they just fail?
Not necessarily. Fabric has a built-in FIFO queue. So if your job gets throttled, it automatically retries when capacity frees up. You'll get a throttling message, but it's not the end of the world. Your job will eventually get its turn.
That's reassuring. So it's not a matter of first come, first served, but rather a managed system that ensures everyone gets their fair share of compute resources.
Exactly. Fabric tries to be as fair and efficient as possible when allocating those resources, but there are ways to potentially bypass the throttling, at least temporarily.
Oh, tell me more. I'm always looking for ways to optimize my workflow.
Fabric has a feature called bursting, which can be your secret weapon for handling those occasional spikes in demand. It lets you use up to 3 times the purchased Spark vCores for faster workload execution.
Wait, so I can temporarily exceed my capacity limits? That's pretty cool. But you mentioned a trade-off earlier. What is it?
The trade-off is that while bursting helps with concurrency, running more jobs at the same time, it doesn't increase the maximum number of cores a single job can use.
Ah, so it's like adding more lanes to a highway but not increasing the speed limit. You can get more cars on the road, but they won't individually be going any faster.
That's a great analogy. It's about finding the right balance between overall throughput and individual job performance. And if you need even more control, there's something called job-level bursting.
Okay, job level bursting, what's that all about?
With job-level bursting, admins can configure specific pools to use the maximum Spark cores with the burst factor. So, for example, a workspace on an F64 capacity, which typically has 128 Spark vCores, could potentially use up to 380/84 vCores with this feature enabled.
Wow, that's a significant boost. It sounds like job level bursting gives admins a lot of flexibility to optimize for specific workloads or situations where they need to prioritize certain jobs.
It definitely does. It's a powerful tool, but it's important to use it judiciously, as it can impact the performance of other workloads running on the same capacity.
All of these options are making me realize how much control I have over my Spark environment in Fabric. It's a lot to take in, but it's empowering to know that I can fine-tune these settings to match my specific needs.
Absolutely. And we haven't even scratched the surface of some of the more advanced features like high concurrency mode.
Well, I'm all ears. High concurrency mode sounds intriguing. What's that all about?
High concurrency mode is a game changer for interactive data exploration. Imagine this, you're working in a notebook running multiple cells, and each cell needs to execute a Spark job. Traditionally, each cell would need to start a new Spark session, which can take time.
I've definitely experienced that. Waiting for those sessions to spin up can be a real productivity killer, especially when I'm in the flow of analysis.
Exactly. But with high concurrency mode, multiple items like those notebook cells can actually share the same Spark session.
Wait, share a session? Wouldn't that lead to conflicts or data overwrites? I'm imagining variables getting mixed up and causing chaos.
That's a valid concern. But Fabric has a clever solution for that. It uses something called REPL cores. Think of these as isolated compartments within the Spark session, preventing those variable overwrites and conflicts you mentioned.
So it's like having multiple virtual data scientists working within the same environment, each with their own dedicated workspace.
That's a great way to visualize it. Each notebook cell or interactive job gets its own REPL core, ensuring that its variables and operations are isolated from others. And the beauty of this is that it leads to a much faster and more responsive experience.
I'm starting to see how this could be a game changer for interactive analysis, but you said there are some conditions for session sharing.
Yes, there are a few limitations to keep in mind. First, the sessions need to be within a single user boundary. Second, they need to have the same default lakehouse configuration. And lastly, they need to have the same Spark compute properties.
So it's not a free-for-all where anyone can share any session. There are some ground rules to ensure consistency and prevent conflicts.
Exactly. But within those constraints, the speed benefits are significant. We're talking about session start times that are up to 36 times faster than a standard Spark session.
36 times faster. That's a massive improvement. It sounds like high concurrency mode could be a real game changer for data scientists who are working with notebooks and need those quick interactive feedback loops.
It definitely is. It's one of those features that once you experience it, you wonder how you ever lived without it. But let's not get ahead of ourselves. We've covered a lot of ground already, and there's still much more to explore.
You're right, this is just the tip of the iceberg. We still need to dive into job admission and queuing, and you mentioned an AI-powered auto-tune feature that I'm dying to learn more about.
Those are both fascinating areas, and they really showcase how Fabric is pushing the boundaries of what's possible with Spark.
Well, on that note, maybe we should take a short break and come back fresh to tackle those topics in our next segment.
Sounds good to me. I'm looking forward to diving deeper into the world of Spark optimization.
All right, we're back and ready to dive deeper into the world of Spark and Fabric. We just explored all the options for configuring Spark compute. But now I'm curious about what happens when things get a bit crowded. What if everyone's trying to run their Spark jobs at the same time? Does it turn into a data center demolition derby?
Well, it could if Fabric didn't have some clever traffic management in place. That's where job admission and queuing come in a system to ensure smooth sailing even during rush hour.
Okay, walk me through this. How does Fabric decide which Spark jobs get to run first?
It uses an optimistic approach, actually. Imagine it as a friendly host at a restaurant saying, "Sure, come on in, we'll find you a table." Fabric tries to be as accommodating as possible when it comes to new Spark jobs. It looks at the minimum core requirement for a job and checks if there are enough cores free in the Fabric capacity. If there are, the job gets the green light and starts running right away.
So far, so good. But what if there aren't enough cores available? Does everyone just have to wait in line?
It depends on the type of job. Interactive jobs, like those running in a notebook, are treated differently from batch jobs.
Why is that?
Think about it. When you're working in a notebook, you want those results immediately. You're exploring data testing code. You need that quick feedback loop. So if there aren't enough cores available for an interactive job, Fabric will let you know and suggest canceling a running job, increasing your capacity, or trying again later. It's like the host saying, "I'm so sorry, there's a bit of a wait. Would you mind trying again later, or perhaps we can find you a smaller table?"
Makes sense. Those interactive jobs need those resources right away. But batch jobs are a bit more laid back, right? They can afford to wait their turn.
Exactly. Batch jobs are like those diners who are happy to have a drink at the bar while they wait for a table. They're not in a rush. So if a batch job can't get the cores it needs, immediately it gets added to a queue.
So there's an actual queue for Spark jobs in Fabric. Is it anything like those infamous lines at the DMV?
Thankfully, it's much more efficient than that. It's a FIFO queue, meaning first in, first out. Jobs are processed in the order they were submitted. And while they're waiting, the system automatically retries them as cores become available.
That's pretty slick, so I don't have to manually resubmit my jobs if they get queued. Fabric just takes care of it.
Precisely. It's like having a virtual assistant constantly checking for open tables and seating your job as soon as one becomes available. But there is a time limit for how long a job can stay in the queue.
Oh, interesting. What's the expiration date on a queued Spark job?
The queue expiration is set to 24 hours. So if a job has been waiting for more than a day, it gets kicked out of the queue.
Okay, so there's a bit of a sense of urgency there. It's not a set it and forget it situation. I need to be mindful of that 24-hour window. But what about the queue itself? Is there a limit to how many jobs can be waiting at the same time?
Yes, there is. And the size of the queue depends on your Fabric capacity, SQU. It's like having different sized waiting areas based on the type of restaurant you're at. For example, an F64 capacity, which is a pretty popular spot, has a queue limit of 64 jobs.
So if I'm working with a smaller capacity, I might hit that queue limit more quickly.
That's right. And if you do hit the limit, any new jobs you submit will get throttled, just like we discussed earlier. It's like the host putting up a sign that says, "Sorry, we're fully booked right now. Please check back later." But remember, those queue jobs are automatically retried, so they're not lost forever.
This whole system is making me think of Fabric as a bustling data restaurant with a friendly host managing reservations, a bustling queue, and maybe even a VIP section for those high-priority jobs.
I love that analogy. It really captures the essence of how Fabric balances resource allocation and ensures everyone gets a chance to dine on their data. But there's another layer to this whole resource management story that I think you'll find fascinating.
Oh, I'm all ears. Tell me more.
Remember we talked about auto-scaling, where Spark dynamically adjusts the number of nodes based on the workload. Well, it turns out that when auto-scaling is enabled, Jobs actually start running with their minimum node configuration.
So they're not starting with all the cores they could potentially use. Why is that?
It's all about being efficient. Think of it as starting with a smaller table and then asking for a bigger one if you need more space. It wouldn't make sense to start everyone off with a huge table when they might not even need it.
That makes sense. But doesn't that mean some jobs might be running with fewer cores than they could be using? Wouldn't that slow things down?
It's possible, but here's the clever part. As the job runs, it can request more cores if it needs them. This is where that job admission control we talked about earlier comes into play again.
So it's like raising your hand and saying, "Excuse me, can we get a bigger table, please? We have more guests joining us."
Exactly. And if there are cores available, Fabric will happily grant that request. But if not, the request is denied, and the job keeps running with its current configuration. It's not a failure, it just means the job can't scale up at that particular moment.
So it's a dynamic process where jobs are constantly trying to optimize their resource usage based on their needs and the availability of those resources.
Precisely. And to bring back your restaurant analogy, it's like a waiter constantly checking in on your table, asking if you need anything else, and trying to accommodate your requests as best they can.
I'm starting to see how all these pieces fit together. Job admission queuing, auto-scaling, they all work in harmony to create a smooth and efficient dining experience for our Spark jobs.
They do. And, if you really want to make sure a job gets the maximum number of cores it's allowed, you can actually disable auto-scaling and set the maximum number of nodes manually.
So it's like saying, we know exactly how many people will be at this table, so let's reserve that space up front.
Exactly. This ensures that the job has all the resources it needs from the start. But of course, this approach can impact the availability of resources for other jobs.
Right. It's like reserving a large table when you might not actually need all the seats. It could prevent other diners from getting a table. So it's a trade-off between guaranteeing resources for a specific job and maximizing overall resource utilization.
Precisely. And that's the beauty of Fabric. It gives you these different levers and controls, allowing you to fine-tune your Spark environment to match your specific needs and priorities.
This is all incredibly insightful, but you know what? It also makes me realize how much complexity is hidden beneath the surface of these seemingly simple Spark operations.
You're absolutely right. There's a lot going on behind the scenes to ensure that your Spark jobs run smoothly and efficiently. But Microsoft has done a fantastic job of abstracting away a lot of that complexity, making the experience much more user-friendly.
Agreed. And speaking of making things easier, you mentioned an AI-powered feature that I'm really excited to learn more about. What was it called again?
Yes. The feature is called Auto-Tune, and it's like having a Spark whisperer constantly optimizing your configurations behind the scenes.
AI for Spark tuning. That sounds almost too good to be true. Tell me more. Welcome back. We've been on quite a journey through the landscape of Spark and Fabric. From those initial compute choices to the AI-powered tuning, that's almost like having a data science genie granting our performance wishes.
It's been a deep dive indeed, and like any good exploration, it's time to surface and see what treasures we've uncovered.
Exactly. So for our listeners who are eager to put all this knowledge into practice, what are the key takeaways they should walk away with today?
The biggest one is this. Fabric isn't just giving you Spark, it's giving you a whole ecosystem designed for both power and ease of use.
Yeah.
You've got choices, those quick start pools for when you need to experiment, and the custom Spark pools when you're building a data analysis fortress.
And let's not forget about those node sizes. It's like choosing the right engine for your data race car. Need raw power. Those XX large nodes are waiting.
Absolutely.
Yeah.
But it's not just about brute force. Fabric's intelligent features like auto-scaling and dynamic allocation are like having a pit crew that automatically adjusts your car's setup based on the track conditions. You get the performance you need without having to micromanage everything.
It's all about focusing on the analysis, not the infrastructure. And for those of us who love the fast-paced world of notebook exploration, high concurrency mode is a game changer.
Imagine 36x faster session startups. It's like teleporting your data into the analysis arena. Of course, there are those conditions for session sharing we discussed, so it's not a universal solution.
Right. It's about choosing the right tool for the job. And speaking of the right tools, those job management features we discussed are essential for keeping our Spark workflows running smoothly.
Think of job admission queuing and auto-scaling as the traffic control system for your data highway. They prevent gridlock and ensure everyone gets where they need to go, even during peak hours.
And then there's auto-tune, which is like having a self-driving car for your Spark configurations. It's taking AI optimization to a whole new level.
I'm still amazed by it. Microsoft is really pushing the boundaries of what's possible with AI in the data world, and AutoTune is a prime example of that.
So we've covered a lot of technical ground today, but what I find most exciting is how Fabric Spark empowers users regardless of their technical expertise.
I completely agree. Whether you're a seasoned data scientist or just starting your data journey, Fabric gives you the tools to harness the power of Spark and unlock valuable insights from your data. You don't need to be a mechanic to drive a high-performance car, and you don't need to be a Spark expert to leverage its power in Fabric.
That's a great way to put it. As we wrap up this deep dive, I'd love to leave our listener with something to ponder.
I'm always up for a good challenge. What do you have in mind?
Knowing all we've discussed today about the flexibility and power of Spark in Fabric, what could you accomplish if you fully embrace these features in your own data work? Could optimizing your Spark configurations, experimenting with auto-scaling, or even taking high concurrency mode for a spin be the key to tackling those ambitious projects you've been dreaming of?
That's a fantastic question. It's a reminder that understanding these Spark features isn't just about technical knowledge. It's about expanding your creative possibilities as a data professional.
Exactly. And who
Yeah.
knows, maybe our listener will discover innovative ways to use Spark and Fabric that we haven't even thought of yet.
I have no doubt. The world of data is full of brilliant minds, and I can't wait to see what they create with these powerful tools at their disposal.
Well, on that note, it's time to wrap up this deep dive. Thank you for joining us and sharing your insights on this exciting world of Spark in Microsoft Fabric.
It's been a pleasure. Always happy to explore the ever-evolving landscape of data and share what I've learned along the way.
And to our listener, thank you for joining us on this journey. We hope you've gained some valuable knowledge and feel inspired to explore the endless possibilities of Spark and Fabric. Until next time, keep experimenting, keep learning, and keep pushing the boundaries of what's possible with data.